So if you've made it to this video, hopefully by now you're kind of feeling like you're an equation solving expert. You can tackle any sort of problem I throw at you and it's making sense overall. This video is going to focus on a couple of things that do get kids tripped up. Once they understand the essentials and they know what they're doing, these are the weird problems that kids get to and they just don't know how to react to. So there's three of them here that I want to talk about. First of all, on this problem, there was a problem somewhat similar on the last video where I said, well, there's an x by itself here, so I might as well do a minus 2x on both sides. And it's over pretty much. You just get 6 equals 3 minus 2 is 1, so 1x or just x, and it's done. But suppose you didn't see that and you said, you know what, I want to move the 3x over to the left side. So when you're doing a problem and you decide, you know what, I want to move this guy over, that's fine. You're allowed to do that still. You get 2x minus 3x, which is negative 1x, or just negative x. The plus 6 carries down. But kids kind of get stumped on what's going on over here. I mean, these canceled. Is the problem broken? What can you do here? If there is nothing left on this side, that is really a 0 there, because there's nothing else there. So you just solve this like a normal problem then. You subtract your 6, you get negative x, don't forget about that negative sign, equals negative 6, and when you have negative x, that's really a negative 1x there. We want to get rid of that negative 1 in front of the x. So we divide both sides by negative 1. And when you do that, you get x equals positive 6, just like before. So, quicker to do the other way, yes, but not wrong to do it this way. You just have to realize if there's nothing left over, there's a 0 there. On our second problem, you can probably go ahead and start this one for yourself, see where it takes you. But if you distribute, you get negative 12t plus 20 equals 30 minus 12t. I'm going to go ahead and put my variable on the left side. So I'm going to do a plus 12t on both sides. And when you do that, negative 12t plus 12t, those actually cancel out. That's a 0t, and that just goes away. Well, the unfortunate thing is it went away over here too. Negative 12t, they canceled on both sides. So all I have left here is 20 equals 30. There's no more variable in that problem. That's a problem for us. 20 obviously does not equal 30. That's not correct. So this problem has no answer. We would say either no solution, because 20 clearly doesn't equal 30, or the symbol for that in math that we typically use, it's like a 0 with a line through it like this. So there is no answer to that problem because both of our variables canceled. All we got was a number equals a number, and it wasn't true. So there's no solution. I took the exact same problem, but tweaked it just a little bit. And on this one, I'm going to power through it real fast, just like before, get us back to where we were. It was negative 12t plus 20 equals 20 minus 12t. When we added that 12t on both sides, the only thing I did different on this problem is I turned that 30 into a 20, basically. The variables still cancel out on both sides, but we end up with 20 equals 20. So this is a true statement. Even though our variables canceled, 20 always equals 20. That's true. So the way we say that, that's always going to be true no matter what we do for t, we say that all real numbers are solutions. So every number you can possibly think of, if you plug in that problem, is going to work. In our symbol for all real numbers, it's like an R, but it has an extra vertical bar. So you do 2 vertical bars, and then you just make a little R like that. So everything works in this problem.